Learning target 36 says I can solve trigonometric equations. So for this learning target, you're going to be given an equation, and the idea is that you want to solve them or find all the angles so that when you plugged in those angles, this would make a true equation. So our goal is going to be to find all possible angles that will satisfy this equation. So, the first thing that we're going to do is we're going to do a little bit of algebraic manipulation until we get down to the point where we have just sine of theta equals a number. So we're trying to get it down to just sine of theta equals something. So right now we have a plus 1, and we want to get rid of that plus 1 by subtracting 1 from both sides. So we have negative 4 sine theta equals 2. And then we have this negative 4 multiplied in front of the sine. Again, we want to get sine by itself, so we're going to divide by negative 4 on both sides. And we get sine of theta equals negative 1/2. So 2 over negative 4 simplifies down to negative 1/2. So let's think about what this means within the context of our unit circle. So for the sine of an angle to be negative 1/2, that means wherever on the unit circle our angles land, they're supposed to have a y coordinate of negative 1/2. So remember, the sine of an angle is going to be the y coordinate wherever your angle ends up. The cosine of an angle will be the x coordinate wherever your angle ends up. So, let me get rid of this so we can actually draw it on there. Let's think about where our y coordinate is negative 1/2 on our unit circle. Well, remember, this is our y-axis, and this is where y is positive, and this is where y is negative. So it's down in this half of the graph where you're going to get negative 1/2 as your y value. So in particular, it's going to be halfway between 0 and negative 1. So negative 1/2 will be down here. And so the 2 points on the unit circle that have this y coordinate are right over here and right over here. So let's draw in those angles. One angle that ends here, one angle that ends here. And so what we want to come up with is a way of describing all possible angles that end right here or that end right here, such that you have a y coordinate of negative 1/2. Now let's draw in our little reference triangles where the angles end up. And remember that since we're in the unit circle, these hypotenuses are each going to be 1. And since we're supposed to have a y coordinate of negative 1/2, that means that this distance here and this distance here will be 1/2. So these lengths should start sort of reminding you of some of our special right triangles. So let's draw a picture of one of our reference triangles to start. So I picked this one over here, and let's just draw that bigger over here. So we know that the hypotenuse is 1 because anywhere on the unit circle, we know that the distance from the center out to the side is 1. And then since this is a y coordinate of negative 1/2, we know that this length over here needs to be 1/2. Now remember, when we talk about like lengths in triangles, even though like within the graph this is a y coordinate of negative 1/2, if we're talking about the length of the triangle, we usually don't, call a length in a triangle a negative number. So let's consider that to be positive 1/2. So what we want to do is we want to think about what is this little angle here. And if you look at your reference sheet that has the 30, 60, 90 and 45, 45, 90 triangles on it, you'll see that there's a special right triangle that looks like this, where across from the 30-degree angle there's a 1/2. Across from the 60-degree angle there's root 3 over 2. And then the hypotenuse is 1. So notice that this little reference triangle is just a little 30, 60, 90 triangle. So we know that this angle is 30 and this angle is 60. But remember, our goal is to find angles that start here and end over here, or that start here and end over here. So let's think about those two possibilities. So let's first talk about this one here that starts here and ends over here. Let's think about what that angle would be. Well, we know that this little angle is 30 degrees, and this triangle is perfectly identical to this triangle. So if this little angle is 30 degrees, this little angle is also going to be 30 degrees. So let's think about what this whole angle starting here and going around like this and ending here, let's think about what that whole angle is going to be. Well, this little part is 30, and we know that this whole angle here is 180 degrees. So we have 180, and then we're going to add on 30 to it. So this angle will be 180 plus 30, which is 210. So one of our possible angles would be 210 degrees. However, you could have also ended up at this angle by going around here and then going around by another full circle. So remember, you can go around the unit circle however many times you want. So we could have gotten to this angle by going around this way by 210 and then going around by another 360 degrees, or another 360 degrees after that, or another 360 degrees after that. We can add on 360 degrees or subtract it off however many times we want. So you can actually have 210 degrees plus 360 degrees however many times you want. So we write out that 210 plus 360n, where n is any integer, that's sort of one set of solutions. So we could have gotten to this angle, we could have gotten over here by starting here, ending here, but we could have then added on as many 360s as we want, and we would still end up in the same spot. So we would still have the same sign value. So now let's start thinking about this angle over here. Now, we know that this little angle is 30 degrees, but if we're thinking about starting here and ending up over here, that angle is not a positive 30 degrees, because remember, when you go the opposite way around the unit circle, we're going to start talking about negative angles. So if we start here and go this way around the unit circle, we're going to say that we're taking negative angles. And so if this little angle here is 30, to start here and end down here, that would be a negative 30 degrees. And again, we can add on 360 however many times we want. Now, you could have thought about this angle over here in a different way. So you could have thought about it as we're starting here and going around this direction, ending over here. And so another possibility for this set of angles would have been to do the following. So you go around like this, you end over here. So let's think about how many degrees that is. Well, an entire circle would be 360, but we want to sort of backtrack by 30. So if we go around by 360 and backtrack by 30, that's like doing 360 minus 30. So another possibility for this set of angles would have been to say 330 plus 360n. So either of these two describes angles that end here. This one describes angles that end here. So this would be the set of all of our answers. And again, it is possible to write them slightly differently. Whoops. Okay, so now let's try another example. Okay, so for this equation we have 4 times cosine of theta plus 6 equals 3. So again, the first thing that we're going to do is we're going to do a little bit of algebra, and this time our goal is going to be to just get cosine of theta equals a number. So let's first subtract 6 from both sides. So we get 4 cosine of theta equals 3 minus 6 is negative 3. And then we have the 4 multiplied in front of the cosine, so we want to divide both sides by 4. So we end up getting that cosine of theta equals negative 3/4. So let's think about where on the unit circle you would have a cosine of theta that was negative 3/4. Now remember that cosine of theta tells you the x coordinate of the point wherever the angle ends up on the unit circle. So let's think about on the unit circle, where do you have an x of negative 3/4? Well, this is the x-axis. Over here we have positive x's. Over here we have negative x's. So we want to look for where the x coordinate is negative 3/4. So that'll be 3/4 of the way between 0 and 1. So that'll be... Make the picture bigger for a second. So that's going to be over here. Negative 3/4. And so we have two different options for where our angle could end up. It could be right here, or it could be right here and still have that x value of negative 3/4. Now, we could draw in our little reference triangles and start thinking about the sides in our reference triangles. However, if you notice, what we're going to know about our reference triangles is that this length is 3/4. And if you think about the special right triangles that we know, we have the 30-60-90 and we have the 45-45-90, and in neither of those two triangles do you have a length of 3/4. So we're not going to be able to just use our special right triangles to get some exact values. Instead, we're going to have to use our calculator. So... to find one possible angle that would give you a cosine of negative 3/4, well, one thing that you could do is you could take the inverse cosine of negative 3/4, and that would give you one possible angle that would give you a cosine of negative 3/4. So that would be one thing that you could do to get one of the angles. So what we're going to need to do is use our calculator. So, as a reminder, to find inverse cosine, you want to look at the cosine button on your calculator. And if you look right above the cosine button on your calculator, you're going to see notation that looks exactly like this. And so what you want to do is you want to hit the second button on your calculator, and then the cosine button. And what you should get is you should get this notation right here. And then you're going to type in negative 3 divided by 4, close the parentheses. And what we end up getting is about 138.59. So let's think about which angle that's giving us. So that's giving us an angle that's like close to 140 degrees. So what that's telling us is it's telling us this angle here. So this angle here is 138.59. So one possible set of angles would be 138.59 degrees, but then again we can keep going around and around by another 360 as many times as we want, and so we want to add on this plus 360n, where n can be any integer. So this describes all the angles that end right here. But we still need to think about all the angles that end over here. Well, if this is a positive 138.59, this angle here would be a negative 138.59. And again, we can add on 360n however many times we want. Now, another thing that we could do, the same way that in the other problem, there would be multiple different ways of expressing certain, the set of angles that end here. For this set of angles, what you could have done is you could have gone around by 360 and backtracked by the 138.59. So that would be another different possible way of doing it. but visually to me it makes more sense to just do negative 138.59. So this is the set of all possible answers to this equation. So let's quickly summarize the steps that we've used for this learning target. So the first thing that we did was we took our equation and we did some algebra to get it down to the point where it's just cosine of theta equals a number or sine of theta equals a number. And then we thought about where on the unit circle do we get that sine value or do we get that cosine value. We sort of draw in the possible angles and draw in the possible reference triangles to help us. Now, depending on what this number is, you might have to just use inverse trig to find one possible angle and then just sort of reason through what the other possible angle would be. If this value was a nice value like 1/2, 1 over root 2, root 3 over 2, those nice special side lengths that you always see in the 45, 45, 90 and 30, 60, 90 triangles, if this was one of those nice values, you'd be able to just sort of like fill in the values on these reference triangles and go from there. But if this is a number that's anything else other than like 1/2, root 3 over 2, 1 over root 2, you're just going to have to use your calculator, do inverse trig to find one of the angles, and then just sort of use that to sort of reason through how you would get to the other angle. Now remember that whatever angle you come up with to describe an angle that ends here first, you then have to add on 360n, because you could keep going around the unit circle however many times you want by an extra 360 degrees and still end at the same spot. So it's important to add on plus 360n for n in the integer at the end.